Okay, today we are going to talk about linear functions. We're looking at some word problems here. So I apologize if we were in class, I had these printed and ready to give to you, so you didn't have to copy everything down, but please work through them with me. So example 1, as dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius as a function of the height in kilometers, assuming the linear model is appropriate. Okay, this right here tells us, this is just asking us to write the equation of the line. Now, we do have to be a little bit careful. We want to make sure we have the correct thing for x and y. This is the one place where people mess up on these. It says to express temperature as a function of height. When I'm talking about the function piece, that's your y. So the temperature as a function, that tells me that my temperature is my y and my height is my x. That is the most common mistake. So if something is a function of, then that goes in the y position. Okay, so to write the equation of a line, we need some points, and we have that. Ground temperature is 20 degrees Celsius. So if it's on the ground, your height is 0, and that temperature is 20. And when the height is 1, the temperature is 10. So now we need slope and y-intercept. So slope. y2 minus y1 over x2 minus x1. So our slope is negative 10. Y-intercept I've actually kind of given to you, but if you didn't catch that, if you plug into y equals mx plus b, you can put either order pair in. So if I did the first one, my y is 20, slope is negative 10, x is 0, plus b, so the y-intercept is 20, which you could tell from here because the y-intercept is the value of y when x equals 0. Okay, I'm going to, instead of using x and y, I'm going to follow the variables in the problem. We used h for the x and t for the y. So it'll be t equals negative 10x plus 20. B, what does the slope represent? So we find slope by doing change in y over change in x. If you look back here, when we calculate this, it tells you exactly what it is. My 10 and my 20, those were my temperatures. Those were degrees Celsius. My 1 was my height in kilometers. The fact that it's negative tells me the temperature is dropping. So, whoops. The temperature is falling 10 degrees Celsius per kilometer. Okay, there are other ways you can state that. What I'm looking for, I expect you to use the number in there somewhere. So I expect you to use the 10. And I expect labels, degrees Celsius per hour. Or you could say the temp falls 10 degrees Celsius for every kilometer that you rise. C, the temperature at a height of 2.5. So if I plug 2.5 in for my, and I just realized I have a mistake because I told you I was using h right there and I put an x anyway. Whoops. Okay, if I plug in that, we get negative 25 plus 20, which would be negative 5 degrees Celsius. So just writing the equation of a line and answering some questions about that equation. We'll do a couple more of these. Example 2. Jason leaves Detroit at 2 p.m. and drives at a constant speed. He passes Ann Arbor 40 miles from Detroit at 2:50 p.m. Express the distance traveled in terms of time elapsed. Alright. Since I want my distance in terms of time, that's telling me that the time is my x and the distance is my y. So we need the equation, we need 2 points. At 2 p.m., that's like our beginning, so I'm just going to call that time 0. Then the distance, at the beginning, it hasn't traveled anywhere, so it's really a distance of 0. Okay, you can convert your time into hours or leave it in minutes. I didn't specify, so let's just go in terms of minutes. We started at 2 and we end at 2:50, so that's a time of 50 minutes. And my distance, we were 40 miles. Okay, so slope, y2 minus y1 over x2 minus x1. You get 4/5, or 0.8. Y-intercept, you can plug into y equals mx plus b. You're just going to get that your b is 0. So my equation, if I use t and d, you could do x and y. Didn't specify here, but my distance is 4/5 t. So part B, interpret the slope. So my slope, my 40 was miles, and my 5 that came from the x, that's minutes. Alright, so this tells me that it travels 4 miles every 5 minutes. Part C, if he continues to drive at the same speed, how far will he have driven by 3:15 p.m.? So since we left our time in terms of minutes, you have to think how much time has elapsed. If we started at 2, then at 3:15, that's an hour and 15 minutes, so that's when our time is 75. So we plug that in. And we get 60. So how far will he have driven? 60 miles. One last example for today. The manager of a furniture factory finds that it cost $2,200 to manufacture 100 chairs in one day, and $4,800 to produce 300 chairs in one day. Express the cost as a function of the number of chairs, assuming that it's linear. So cost as a function, that means the cost is my y, and the number of chairs would be my x. So it costs $2,200 to make 100 chairs. It costs $4,800 to make 300 chairs. So slope y2 minus y1 over x2 minus x1. So we get 2600 over 200, or 13. Plug into y equals mx plus b. I'll just use the first order pair. If we subtract that 1300 over, we get 900 for our b. So my equation, y equals mx plus b, I used n and c. My cost is 13 times the number of chairs plus 900. So the slope, 2600, that represented the dollars. The 200 was the number of chairs. So it costs $13 for one chair. See the y-intercept, that's my 900. Your y-intercept is the value of y even when x is 0. So that means when my number of chairs is 0, my cost is still 900. So $900 are the fixed costs. This is the cost if no chairs are produced. Okay, so that is the end of this section. Your assignment is the handout that I am posting along with this. Please email me if you have any questions or concerns.